Welcome to Spring LIB.
This is the problem number 26. An anti-Hermitian or skew Hermitian operator is equal to its Hermitian conjugate, and that means it is given here. This is a Hermitian or a skew Hermitian, and dagger is equal to minus q for skew Hermitian operator. Now, in the first part, that is A part, so that the expectation value of the anti-Hermitian operator is imaginary. That we have to find the expectation value of the q, and it is defined as, let's assume some vector that is psi, and it is q and psi. If I write q on this side, then I have to take the complex conjugate and the transpose under the, we will write here q dagger and the psi and psi. Now it is given that the q dagger is equal to minus q, then it will be minus q psi sorry this q dagger psi is equal to, that is q psi and psi, and if I take the complex conjugate of this, so this can be written as minus, so if I transfer this q on this side, then it will the complex conjugate of this, and this is nothing, this is q, so hence this is minus q and complex conjugate. That means this is the, if I find out the complex conjugate, suppose z is equal to x, suppose z is equal to 2y, z1 is equal to y. If I take the complex conjugate a, it will be minus 2y. That means it is negative to each other. If I take the real value, suppose z2 is equal to 3 and z2 complex conjugate will be also 3. So it is clear the expectation value of the q are imaginary. So q, expectation value of the q is imaginary. Now the B part of this question, so that the commutator of two Hermitian operator is anti-Hermitian, and how about the commutator of the two anti-Hermitian operator? Let us assume two Hermitian. Here it is so that the commutator the two Hermitian operator, and the Hermitian, let us assume two Hermitian operator A and B. If they are Hermitian, then A dagger is equal to A, and the B dagger is equal to B. Now we have to show that the commutator relation of these two Hermitian. So let's find out the commutator of this A dagger A and B. And we have to take the dagger of this, then it will be A B dagger minus B A dagger, and there is a rule, if we take the dagger then it will go, that is B dagger and A dagger. Similarly here this will be A dagger and the B dagger, and it is given here that is B dagger is equal to B and A dagger is equal to A. It is B and this is A minus A and B, and if I take a minus here, it is AB minus BA, and it is nothing, it is minus commutator relation of the A with B. So because the A this commutator relation of this A dagger is equal to minus, hence this commutator relation of the A and B are skew Hermitian. Thus commutator relation of two Hermitian operator is skew Hermitian or anti-Hermitian. Now we have to check about what about how about the commutator of two anti-Hermitian operator. So if case number 2, for anti-Hermitian A dagger is equal to minus A and B dagger is equal to minus B. Let's do this again, that is A and B dagger is equal to A and B dagger minus B A dagger. Again this is B dagger, A dagger minus A dagger and the B dagger. This time this B dagger is equal to minus B and A dagger is equal to minus A. Similarly here A dagger is equal to minus A and this is minus B. Again this is, these are the operator, all are operator. So this is B A minus A B. Again we take the minus sign here, then we can add here A and B minus B and A, and this is nothing, it is commutator relation of the A and B. So again the commutator relation of the anti-Hermitian matrix is also a anti-Hermitian. Hence commutator of two anti-Hermitian is also a anti-Hermitian. The conclusion is that either Hermitian or anti-Hermitian have are anti-Hermitian. That is, Hermitian anti-Hermitian uh, commutative relation are anti-Hermitian. It is for only two Hermitian or anti-Hermitian operators. Thank you.